Okay, so let's talk about secant and cosecant. And let's just, like always, let's establish some patterns here and then hopefully shorten it up a lot. So, first thing is, and I hate having to write this stuff over and over and over and over. So, we're only going to do this once or twice. And then once we establish the patterns, we won't have to worry about it again. So, if we say, okay, so here's our values for x, so this would be our sine x. Well, then this would be our cosecant x's. So you'd say, well, let me see, pi over 2 comma 1 at pi over 3, cosecant is like 1.15. At pi over 4, cosecant is like 1.4. At pi over 6, cosecant is 2. But at 0, it doesn't exist. And as we recall from our early days in algebra 2, looks like that means it's an asymptote. So if we go back the other way, well, what do you know? It kind of does the same thing. And I know it's a terrible picture. Kind of does the same thing, but then we get to pi, it doesn't exist again. We get an asymptote. So what happens is we look at it and we say, you know what? It looks like it's curving up, like it's making a nice curve here. And if we wanted to, we could get values closer and closer to pi, and we'd say that they're getting infinitely big. They would sure enough be approaching that. So the curve is fitting right inside the asymptotes like this. And then somebody says, it looks like a parabola. Well, okay, it looks like a parabola. Technically, it is not a parabola. A parabola would be expanding on the right and left for infinity. This is trapped between the asymptotes and it's not expanding. And then somebody says, you know what? I kind of noticed something weird about this. You say, hold on. If I graphed my cosine curve, not my cosine, if I'd graphed a sine curve, the sine curve would have looked kind of, and I know this is a terrible picture again, the sine curve would have looked kind of like this. They've got that one point in common right there. And then where the sine curve is on the center line, the cosecant curve doesn't exist. Well, what it turns out is this is going to be our shortcut. If you think about it like sine and cosecant are reciprocals of each other, and reciprocals are just flipping. And I know this is not a very sophisticated way to think about it. You say, oh, so if I have a sine curve and I want to draw the corresponding cosecant curve, then I just kind of flip it over. They have that point in common, the max min they have in common, and where the sine curve is on the center line, the cosecant curve doesn't exist, and everything else just kind of flips over. That's the shortcut we're going to come up with here in just a little while. So somebody says, all right, that's kind of weird, but let's build on that. Okay, so let's do it for a cosine and a secant. All right, so let me see. We're graphing the secant. That's what we want to graph. So let me see we've got 1, 1. So let's call that 1.4. So anyway, when x is 0, secant is 1. When x is pi over 4, secant is 1.4. When x is pi over 2, it doesn't exist. If it doesn't exist, that means we got an asymptote. Somebody says, so you didn't do all the other ones. I know, because the other ones are just going to kind of fit onto the curve, and I'm getting lazy now. So over here, we're at way down here at negative 1.4. What the heck? And then we're down here at negative 1, and then back to negative 1.4, and then back to does not exist, and then back to positive 1.4, and then positive 1. And let's see. Okay. So anyway, Okay. I'm sure I told everybody my daughter has COVID now too, but I'm definitely better. All right. So anyway, if we start connecting the dots, you think, wait a second, it's kind of curving up. Well, what do you know? You get the same pattern again. You get that same pattern. So curving down beside the asymptotes, you're going to run infinitely along beside the asymptotes. So you think, well, you know what? That looks very familiar. Also, when you graph a cosine curve, so that's root 2 over 2 right there. A cosine curve would have looked like, this is a terrible drawing. Cosine curve would have looked something like this. So once again, it's the same situation. For cosine and secant, you're just flipping them. You're flipping the, not to cough. So you're taking the cosine curve and just kind of flipping it over. Everywhere that the cosine curve crosses the center line, the secant curve doesn't exist. That becomes our asymptotes. And they have that point, that max min point. They always share that max min point. That point is in common. Okay. So anyway, that's the setup. That's the setup for these guys. So what we'll do is we'll do a couple of examples where we build on it here. But I'm going to make those as separate videos so that these aren't too long and too laborious for you guys, that is.